Hey guys, this is Steve from DoraHacks, and today we're very happy to host two amazing engineer and developer from Protocol Labs and Fleek to introduce two amazing workshops on Filecoin. So now we are running Filecoin Grant 1 on HackerLink. We're using quadratic funding and voting to support early stage Filecoin ecosystem projects. The grant is still live, so make sure to go on hackerlink.io/grant to support the Filecoin ecosystem project that you may find interesting and contributing a lot to the growth of Filecoin ecosystem. And yeah, today we have two workshops for you guys. If you have any questions, feel free to ask on the Bilibili channel or YouTube live streaming session. And if you want to engage with the mentors today, feel free to reach out to us and we'll pass on the questions to the host today. So first, we have Yusef Napora, the documentation engineer of Protocol Labs. He will introduce the topic of how to mint NFTs from your browser with nft.storage. So yeah, without further ado, let's welcome Yusef to take on from here.
Yeah, thanks very much. I'm Yusef. I'm from Protocol Labs, and what I've been working on for the past few months basically is figuring out how we can best, leverage our technology. We develop IPFS and Filecoin and several other projects that are used throughout the sort of decentralized web ecosystem. But we want to use that technology to help make NFTs as solid and secure and long-lived as possible. And that's kind of where my head has been at the past few months. So I figured I'd share some of that with you guys, and we could see how everything works. So I'm going to share my screen real quick. I have a few slides that I stole from my friend Alan. He has created this sort of thing. And then we'll just jump into a little demo. And if you guys have questions, we have good answers. So minting NFTs in the browser. How does that work? I'm going to talk about IPFS and Filecoin here because that's what I'm familiar with as a PL kind of guy. There are other ways to mint NFTs, but of course we think that this is a pretty good solution. So why is that, right? So, one of the big issues with NFTs currently, right, is that generally speaking, very little data can be stored on a blockchain where the NFT is defined, simply because data storage is really expensive when you need global consensus like on a blockchain. So most NFTs are really fancy links, right? They link out to content elsewhere. Usually there'll be a metadata manifest, and then that manifest will link to more like images, music, whatever. But links are fragile, right? If they, especially HTTP links that we're all familiar with on the web, like they're tied to a single domain, and the naming scheme within that domain can change at any time. Content can change at the other end of a link based on pretty much anything. Like you can tell a web server to return different content for any number of reasons. So that's a poor fit in our view for something that needs to be written immutably to a blockchain. And you're never going to be able to change this link later. So you want something that is as future-proof as you can make it. And we think that IPFS helps. So quick overview of IPFS if you've never used it or heard about it before. So when you add data to IPFS, first you add it to your local node. It produces a CID, or content identifier, this like little random seeming string down here. And that's a cryptographic hash of the content itself. So it's derived from the content. If you change the content at all, like flip a single bit, you'll get a new CID. This kind of gives us a way to give every single piece of digital content in the world a unique identifier that won't collide, ideally, because these are the big space. We have 256-bit hash as the default, so collisions are very rare. So basically, now IPFS, you can think of it as like a giant key value storage database. And when I request content from, I say, here's the CID, the content ID, please fetch me this data, IPFS. Now, this node over here, okay, it has a copy, and now it can provide it to a third node, right? Now there's two locations where this content can be fetched, and so on. That this third node now has a copy. Whenever anybody is requesting it, they'll be eligible. If they get the request, they can provide it. So that's kind of cool. Now, instead of our content being tied to a single server, anybody who has it can provide it, and ideally, the closest person in terms of network latency would be the one that resolves the request the fastest. And what's kind of cool too is that like pieces of a large file can all be provided from different people. So similar to, I guess, how BitTorrent works. So then, yeah, the data is retrievable from any of these nodes, but there's a caveat, which is that what if everybody just stops hosting it? Like if all of these nodes drop the content, it won't be resolvable. So IPFS, I feel like there's a fairly common misconception about IPFS that like you put your data onto the network and then the network just sort of takes care of it, right? Like, when in fact, that's not necessarily the case, because if all of these nodes have removed the content, oh, sorry, I jumped ahead a little bit, then it will just disappear. So somebody actually has to be online serving the content for it to be resolvable. And the second caveat is related, which is that your data can get garbage collected because disk space is a finite resource. So if you're running up against your disk space limit, your IPFS node will clear out these sort of these little copies that it made along the way for things that it doesn't know is important, right? Because like as you're browsing IPFS, you store a copy. As long as you have disk space, that's great. But once you start feeling pressure, you'll run this garbage collection. So even though the network is helping you distribute your content, you can't rely on those like extra copies for long-term storage because they're pretty ephemeral. So you can pin your content, right? That's saying, hey, you never garbage collect this, please. And then it will never get removed from your node. And you can also contract with a remote pinning service like Pinata, Fleek. It has a pinning service. Like basically, there's a few providers where they will say, hey, we have a bunch of IPFS nodes. Give us your content. Give us a few cents per gigabyte or whatever the pricing scheme works out to be per. And then we will make sure that this stuff is always online, so you don't have to run an IPFS node yourself. You can still participate in the ecosystem and get all the content addressing benefits. Because like one of the great things about the NFT context for IPFS is that like, let's say that as the NFT marketplace, I want to host the images and so on IPFS for the people who are going to buy these NFTs, but I don't necessarily want to do that forever. Even if that marketplace disappears completely, right? Like if they just go out of business or whatever, if I've bought the NFT and the NFT has an IPFS content ID in it, I can host it myself, and it's still alive. Or I can say, hey, or somebody else, please come and swoop in. And actually at Protocol Labs, this is sort of a side note, but we're working now on taking all the publicly addressed NFTs on Ethereum and other EVM compatible chains and just backing them up long-term using NFT storage, which I'll get to in a second. Whoop, there it is. It's the next slide. This is my first time running through Alan's slide deck, so I'm as surprised as you guys are. But NFT storage, right? This is a service that Protocol Labs is kickstarting, and it's sort of, it does a few interesting things, right? So it acts like a pinning service, where like similar to Pinata, where you can say, hey, please make this data available on IPFS indefinitely. And the way it does it is kind of interesting. So first, it does store it on IPFS, but it also stores it on the Filecoin network, which, if you're not familiar with that yet, it is a decentralized storage network where we have basically a bunch of storage providers called miners who have data centers basically, and they will store your data. And the Filecoin blockchain protocol will ensure that they're doing it, right? They'll be periodically challenged over time to say, hey, you still are storing this data? And if not, there's a penalty and so on. So this is a way to get persistent storage over time without having a single service provider that you have to have a contractual centralized relationship with, right? So, there are certainly there's a lot of use cases for this, and we think NFTs are a good one. However, nft.storage kind of fits into the mix here by giving you like one simple HTTP interface to it all. And it also will take your small NFT data and batch it up into larger sizes for more efficient Filecoin deal making. So it kind of like aggregates and makes it more like friendly to the Filecoin net miner expectations. And so as a result, you get this, you get the content addressing benefits of IPFS, plus you get this decentralized storage persistence layer. And because we're kickstarting this and like really like we are at EL like enthusiastic about the NFT use case, really want to support it, we're footing the bill. Like we're paying the Filecoin storage costs for all NFT storage users. So the service is free to use indefinitely. Like we have no plans to turn it off, basically, as long as we can afford to keep the lights on, is my understanding. And if it ever becomes a financial issue, or like we just, if we had ever decide to discontinue nft.storage, we've committed to at least like, hey, we're going to give you 90 days notice so that you can provide another persistent backup for the storage. Because again, like IPFS gives you that portability. Like if your NFT is referencing this IPFS CID, then even if these Filecoin storage deals expire, you can certainly make another Filecoin storage deal or provide another persistent backing for that data. And the user of the NFT never has to know the difference. It's just like, they were just using IPFS and they never had to know that behind the scenes there was this other blockchain incentivized persistence layer, which is how you think of Filecoins. And that's pretty cool. So, and it's really easy to use, which is another nice thing. Like one thing I've learned as a documentation engineer is that IPFS has not a lot, but if you're not familiar with it at all, there's a bit of a learning curve, right? There's some new concepts. I mean, content addressing is new to a lot of developers, but also, peer-to-peer networking in general is fairly complicated compared to the client-server model. So it kind of adds friction, and especially coming from a web browser context, it can be difficult to like speak the native protocols to IPFS and Filecoin, and it's nice to have an HTTP sort of layer in between. So nft.storage is providing that. It's just a simple, REST-ish kind of API. And then we also have a really nice JavaScript client that what I think is kind of the coolest part about this, so a few months ago, I did a version of this NFT minting tutorial where it was a command line app, but the biggest part of it was like, you construct metadata for your NFT, and then the metadata needs to reference an image and whatever the asset is, and then finally you write something to the blockchain. And so there's like there's a multi-step process. Not a huge deal, but it's kind of fiddly. And so now nft.storage kind of does that for you. So you give it this, a JavaScript object that has the metadata you want for your NFT and a file that has your data, and it'll take this file that's in the middle of this nested structure, add that to IPFS, and then replace in the metadata, just give you an IPFS URI, like just a link you can follow. So it just kind of makes this whole bundling of NFT assets nice and easy. It's like the one-liner for what took me maybe 50 lines of code in the previous iteration without NFT. So that's kind of nice. There's other clients because they're kind of starting from like a generated open API schema. So we have a lot of clients for different programming languages and so on. And so moving on, specifically from nft.storage to our new thing, which is a project that I've been working on for a couple of weeks now. We haven't like launched it yet, but I guess, hey, here I am telling you about it. So please check it out. What we're trying to do at this phase of development is gather feedback. This is NFT School. We're trying to create a resource where people can come and figure out, like, first of all, like, if you're brand new to NFTs, we've got some concept articles, like what are they in the first place? And like, how does content addressing fit into the mix? You can see many under construction placeholders where we're saying like things that we want to talk about. And part of the reason we're leaving it in this unfinished state right now is we want to gather feedback on like, is this really what you want to see from a site like this? So if you're watching this now, and you're like, this is either too low, it's too easy for me, or it's too confusing, anything like that, please, we would really appreciate the feedback as we kind of try and figure out the direction for this. And the other thing too is like we want direct contributions, because our ambition for this site, NFT School, is not to be like a protocol labs or whatever. We like ideally we would step largely away from the content of the site as we build it out, and what we want to do is start soliciting input from people in the NFT development community that may have experiences that complement ours or come from a different perspective. Personally, so far what's there is coming largely filtered through my experience, because I've been so far the primary writer on the site, but my experience is limited, we're very much aware of that and trying to elicit as much external feedback as we can. So that's enough, I guess, talking about the site itself. Why don't we do stuff, right? So I will go back to the NFT School site, because what we're going to do for the demo is try and walk through this end-to-end experience tutorial, which is something that I threw it together using this really awesome Ethereum boilerplate repository called Scaffold ETH. So if you guys have never heard of this before, it's amazing for just quickly getting a Ethereum-powered dApp just up and running without a bunch of fiddling about. And it gives you a lot of handy React components and hooks and just very nice like scaffolding. Okay? And so it's also, if you're just getting into Ethereum development, you can learn a lot by just switching through the different branches on this repo. A lot of people have built out specific examples using the Scaffold ETH starter framework. And then, you can find a lot of interesting techniques just poking around here. So we started there, and we're adding NFT minting to it to kind of see how the whole process works. And let's just run it. So here I am. I've already checked out the code and done npm install because my internet is slow and nobody wants to watch that. So here we are though at the basically clean slate. So I'm going to run a local blockchain simulator basically. This is going to pretend to be Ethereum for me, and it comes with a bunch of fake money. So then once I've done that, I have a smart contract that we'll see in a second, and I'm going to deploy it to my new Nft blockchain. This one will deploy script, and it's going to just compile the contract for me and then deploy that to this little fake Ethereum. So now the contract has been deployed to this address, and the ETH, Scaffold ETH, scripts take care of getting the contract address and the other information that you need to connect to it into the right place so that the front end can find it. So what we're going to do next is build a React front end and run the dev server. So do start. And then this will fire up the little example here, and we can poke at it. And it's really simple. It's I'm just going to show you, how it works. It's not the prettiest thing, but we can walk through, how the minting process works in the app, and then I'll dig into the code a little bit and show you guys what's actually going on. File. Actually, while that's happening, maybe I will open up my code editor so you can see. Samples. So this is the smart contract. It's basically straight out of the Open Zeppelin tutorial, which is they maintain a bunch of really excellent smart reusable contracts, based frameworks, and stuff like that. It's a great resource for getting started with Ethereum development. So they have this implementation of ERC 721, which was the first formal NFT specification on Ethereum, and it's still the most popular and common. And basically what it's doing here, this part where, like I said, little base URIs just to save a few bytes on chain because I'm using the same prefix for all of my URIs. what's actually happening to mint a token is very, very simple. So you have a counter to assign token IDs. Every token gets a new, you increment the counter and that becomes the ID. This is built into the base contract, the ERC 721, is safe mint. Safe in the sense that it checks first to see if the new owner is capable of receiving one of these tokens before it mints it, otherwise it'll get lost forever. And then here's the bit that actually associates the token ID with our IPFS CID, our UID. And that's it. Then you have a new token, it's on the blockchain, and when you look it up, you can get the UID back out of it. And that's sort of the heart of the NFT mechanic is you have saved something to the blockchain, and from there, you can sort of traverse the link to get the metadata and the original asset. Let's see if everything is compiled now. There we go. So, yeah, it's gorgeous. I'm sure you will agree. We can pick an image. Sky. So, hello. This is dog. And now I'm going to say mint. And what's going to happen now is it will be uploaded to nft.storage. And then nft.storage is going to give me back an IPFS URI for the metadata. No! Oh, it failed. So my demo gremlins are clearly not happy. Perhaps I did not. Oh, I skipped an important step, so let's do that. Forgot to get some fake money. So here we are. I have no money. It starts you out with a burner wallet. You can connect, if you have MetaMask or something installed, connect your actual wallet to it. But we're just gonna get some fake money from the local development faucet. Now, if I try this again. It worked. Minted token number 1. Okay, so now, yeah, we can go and view it on this page again. It'll query the blockchain and then download the image from IPFS again. So that's it, really. That's that's all this thing does. Although you can, if you're if you're interested in the mechanics of it, you can manually call any smart contract function from here. This is built into Scaffold ETH, which I think is it's just kind of a cool way to interact while you're in development to see what's going on. So if I wanted to say who is the owner of that first token, for example, choose one photo. All right, but anyway, yeah, that's something to poke at. I think that once you're here, probably what you would want to do, assuming that you're still interested, is go and look at the code and see what we're working with. So for that, we have in here, the important bits are all in this Minter. And really the actual action is happening all in this one function where we're saying, make me a new NFT storage client and upload my NFT, basically. Once I have that, I got a metadata URL, and that's going to be IPFS:// some CID. But since I was fancy earlier and hard coded that prefix into the blockchain, I'm stripping it out here. That's kind of not super necessary. And then the rest is just, this is calling the mint token function on my contract. It gets wrapped in some UI magic that's provided by Scaffold ETH. Once the transaction has been confirmed, we get the transfer event out of the transaction receipt. And that tells us who owns the new token and what its ID is. And that's the bit. So then we have an NFT on Ethereum. And for me, the most satisfying part of this was just one line and I got to throw away so much code that I had to write last time around before nft.storage existed. But I do want to call out one important thing here, which is that I'm playing a little fast and loose here by including the NFT storage key here in line. In a production application, if you guys are going to go run out and build NFT minters based on this code, that's not a safe option because this storage key will be bundled into your front end and then just do stuff with your NFT storage account. So the reason I'm leaving it like this and haven't like on the website on NFT School, I haven't like plastered warnings on there yet, is that I'm hoping by the time we really launch NFT School, NFT storage will have implemented wallet auth, because we're using a auth provider that can integrate with Ethereum wallets. And that's, I think, the ultimate flow here for this, is that you connect your Ethereum wallet to the Minter app. The Minter app then requests storage token from NFT storage using your wallet credentials. And then the user of your app just transparently uploads their NFT storage account. And that way your minting platform isn't, there's not like one centralized account for all NFTs that go through the platform. Instead, each user who interacts with your application can have their own NFT storage and be like, they would have control over it. And I feel like that adds a nice level of decentralization. The next level of decentralization will come when other NFT storage like services are there to be swapped in and out of. So I mean, our grand ambition is for NFT storage to eventually be like one of many entry points into this flow. So we're kind of using it as a proving ground and kind of like get all the use cases sorted out. And we really, we want users. So if you guys have NFTs that need storing, please sign up. It's free. We're going to store your data and it's easy to use. So why not? And as far as NFT School goes, if you guys, you could really help me out by clicking on stuff and telling me what you hate about it, basically, or what you want to see in it. Because I think our resources right now are pretty limited in terms of actual time to write and tutorials and develop them. So it's very important for us to prioritize on the things that you actually want to see. So right now we're starting sort of at the low, or starting with the basics, and we're going to build our way up to more complex examples, ideally involving custom logic, like there's transfer rules, and maybe we could have like some sort of, I don't know, CryptoKitties like breeding mechanic. These are all things that we could do, but we need your help to figure out what you really want to see. So that's my pitch for my slide. Please help me out here and tell me how to do my job. I think that I'm excited about the direction that we're heading with NFT storage, because it's one of the simplest ways to get into the IPFS ecosystem that I've come across. And I've been working on this stuff for a couple of years now. And I think that, I don't know, I think that this whole NFT use case has a lot of potential that is just now being realized. And it's still such early days that there's a lot of opportunity here. So NFT School is us trying to say, we want to be in the middle of this conversation. Currently, I feel like there's still a lot for me to learn. So, but I'm doing my best to, spread the knowledge that I have and build on it as I go. So, please, again, any impressions that you have on the site are useful, even if it's just clicking around. And we have little buttons that say do you really want to see this article, or is this something you don't even care about? So the more you guys click on those, the more I will know what I'm doing with my life. All right. So great. I think that's about all I've got for you guys. I think I might have a couple more slides in here. Yeah, just thanks. And here's me. If you guys want to reach out to me directly, probably I will. I reply to email more quickly than I do to Twitter, because I just have weaned myself off it over the past several years. But I will eventually see it if you tweet at me. But yeah, you got email. And like I said, there's just so much stuff to learn. I can't keep up with everything, but the more you send at me, the better chance I will have of setting a good direction for this site, and hopefully building out a community of NFT devs where we can all hang out and figure out what the next big NFT thing is together.
Awesome. Yeah, thank you, Yusef. We can see nft.storage is a very new and exciting project coming out. And like Yusef have mentioned, we're still at early stage where Yusef really expects to expand his team and expand the community to contribute to the project when it comes to documentation or participate maybe in deeper, research or development to make this project, to take this project to the next level, maybe. And also we can just have fun to see what kind of fun NFT projects can be developed using nft.storage on Filecoin or IPFS network. Yeah, thank you so much for joining us today, Yusef. Guys, audience, if you have any question, if you want to participate in the development or the development of product, the development of the community, feel free to reach out Yusef at his Twitter, at his email link. His email is yusef@protocol.ai. So yeah, feel free to reach out him there. If you have any questions, reach out to us and we can pass on to Yusef after this. Thank you so much for joining us. It's a great workshop. Yeah.
Well, thanks. That's really fun.